to find the equation of the southern boundary of the sidewalk, what I did is I plugged our slope, -20 over 100, simplified it to -1 over 5, and put in the point that we have, which is 100 and 180, or sorry, I used 100, 0, 100. So I got y minus y1, which is 100, equals -1/5 times x minus x1, which would be 0. I simplified that and then solved for y, and we've got y equals 1/5 x plus 100 for the line of the southern boundary. Part B asks, after 33 minutes, sketch a picture of the wet portion of the sidewalk. Find the length of the wet portion of the southern edge of the sidewalk. So here's part B. We have our formula, distance equals rate times time. I converted the rate at 1/2 inch per second to inches per minute, which is 30 inches per minute. And over the course of 33 minutes, we have 990 inches per minute, or 82.5 feet per second. Then what I did was I drew up a new sketch where the sprinkler has now traveled 82.5 feet along its path, so now it's at 0, 82.5, and then knowing that the radius is 20, I know that the northern edge of the sprinkler is going to be at 102.5. Now what we're looking for are 2 points at which the circle intersects our line, so we have to do is plug our value for y, which we got earlier, -1/5 x plus 100, into the equation of a circle with the circle at 0, 82.5. So we come over here, we know that the equation of a circle is x minus h squared plus y minus k squared, where hk is the center of the circle, equals r squared. So then I went ahead and plugged in our y, like I just mentioned, and we've got x squared plus -1 over 5x plus 100 squared equals 20 squared, or a radius squared. And I went ahead and FOILed out -1/5 x plus 17.5 and added the x squared to it and set it equal to 20 squared. You get x squared plus 1 over 25 squared minus 3.5x minus 3.5x plus 306.25 equals, eventually it's going to be 420 squared. And then I combined like terms, and we got 26 over 25, which is just 1x squared plus 1 over 25x squared, and then combined the -3.5x's, and got -7x, and then set the equation equal to 0, added 400 to both sides, or subtracted 400 from both sides, and got -93.75. Now what we need to do is solve for x using the quadratic formula. It's -b plus or minus the square root of b squared minus 4ac all over 2a. And then you can see my work here. Eventually we get x equals 175 plus or minus the square root of 274,375 all over 52. So we should get two solutions, one for the plus, one for the minus. The positive x value is 13.44, and the negative x value is -6.71. So then what we can do is put that into our equation for the line, and we get y equals -1/5 times x, which is now 13.44 for the positive value, plus 100, which gives us 97.312. So now that we have our 2 points at which our southern boundary of the sidewalk intersects with our circle formed by the sprinkler, we can go ahead and create a right triangle with that, plugging in our y2 minus y1 for our length of our triangle that runs along the y-axis, and then x2 minus x1 to get the length of the bottom of the triangle. Use Pythagorean theorem to get c for our hypotenuse, which is 20.55, which answers the question, what is the distance between the 2 points? Okay, so Moving on, we need to find the distance from the southern boundary to the northern boundary running along the y-axis. So we know that 10, which is a line that's perpendicular to this line, is going to be 10 feet across. And so what I did was use a trigonometric function to find this angle here. So what I did is set sine of A equal to the opposite of the hypotenuse, the opposite being 20, the hypotenuse being 101.9.8, which I just got by plugging 20 and 100 in Pythagorean theorem, and then getting 11.31 degrees for A. Now we know that this is 90 degrees, right? This box that we formed here, that is between the line that's 100 feet long and the y-axis. So what we can do is set 90 minus our value for A, which is 11.31. And we get 78.69 degrees is going to be this angle right here. And then what I did was I did another trig function. Sine of 78.69 is equal to the opposite of our hypotenuse, opposite being 10, and the hypotenuse being x, what we're solving for, and that'll get you 110.98, excuse me. So what the problem is asking for, though, is the equation of the line of the northern boundary. So since we have this coordinate, which is going to be our x-intercept, or y-intercept, excuse me, we can put it into y equals mx plus b. We know that our slope is 1/5 from the beginning of the problem. So we get y equals 1/5 x plus 110.198.